Normandy, July 1944. A British Cromwell tank advances down a narrow French lane. The crew feels safe. 14 millimeters of armor surround them. German rifles cannot penetrate it. German machine guns bounce off. Inside the tank, they are protected. Then the Panzerschreck fires. The rocket hits the turret. The shaped charge warps inward. Metal turns to liquid. The jet of superheated copper punches through the armor like paper. Inside the tank, the crew has no warning, no time to react. The penetrator enters the fighting compartment at thousands of meters per second. The gunner dies instantly. The commander is killed by spalling fragments. The loader catches fire. The driver tries to escape, but the tank is already burning. Within seconds, a crew that felt safe inside their armor is dead. The weapon that killed them is simple: a tube, a rocket, a shaped charge warhead. The Germans call it Panzer Shreck, tank terror. Allied soldiers call it the Stovepipe because of its distinctive shape, and British tank crews learn a terrible lesson. Armor does not guarantee safety. The Panzer Shreck kills you inside your own protection. Between 1943 and 1945, German infantry armed with Panzer Schrecks destroyed hundreds of Allied tanks. The weapon turned tank combat into close-quarters ambush, and it proved that a single soldier with an 88mm rocket could kill a crew hiding behind armor that should have kept them safe. The problem facing Germany in 1943 was tactical. Allied tanks were appearing in greater numbers: Shermans, Cromwells, Churchills. German anti-tank guns were effective but required crews, towing vehicles, and prepared positions. Panzerfaust disposable rockets worked, but offered only single-shot capability with limited range of 30 meters. Germany needed something different, something reusable that infantry could carry and fire repeatedly at longer range. The solution came from an unexpected source: American innovation. In 1942, the United States introduced the M1 bazooka, a shoulder-fired rocket launcher that gave individual infantry soldiers anti-tank capability. The concept was revolutionary. One man could carry firepower that previously required an entire gun crew with a towed weapon. German forces captured an American bazooka during fighting in Tunisia in early 1943. Intelligence officers examined it thoroughly. They tested it against captured Allied tanks. The design was brilliantly simple: a steel tube, a rocket with a shaped charge warhead, an electrical firing mechanism triggered by a simple battery. German engineers recognized the potential immediately, but they did not simply copy the American design. They improved it. The German engineers asked a basic question: if 60mm works, what would 88mm achieve? The answer became the Raketenpanzerbüchse, rocket anti-tank rifle. German troops had a simpler name for it: Panzer Shreck, tank terror. The name was accurate. The design improved on the American bazooka in every significant dimension. The rocket diameter increased from 60mm to 88mm. This allowed a much larger shaped charge warhead with significantly greater penetrative power. While the bazooka could penetrate approximately 76mm of armor, the Panzerschreck achieved 160mm. This was enough to defeat any Allied tank from the front at combat ranges. The tube itself was longer, 160 centimeters compared to the bazooka's 138 centimeters. This increased both accuracy and muzzle velocity. The rocket traveled at 110 meters per second. Effective range reached approximately 150 meters. Maximum range stretched to 180 meters. Beyond 150 meters, wind drift and trajectory drop made accurate hits unlikely. The firing mechanism used electrical ignition copied from the American design. A simple trigger sent battery current to the rocket motor. The weapon required a two-man crew for effective operation. One soldier aimed and fired. The second loaded rockets and watched for backblast danger zones. Proper crew coordination was essential for survival. The Panzerschreck produced tremendous backblast. The rocket motor exhausted directly rearward, creating a cone of superheated gas and flame extending several meters behind the weapon. Anyone standing in this zone during firing would suffer severe burns or death. Early production versions lacked any blast shield. Gunners frequently suffered facial burns and hearing damage from rocket exhaust. Later models added a small curved blast shield mounted near the firing grip. This protected the gunner's face from the worst of the backblast. but the weapon remained inherently dangerous to operate. Training emphasized proper positioning, awareness of what lay behind the firer, and immediate relocation after shooting. Production began in late 1943 at multiple German factories. By war's end, over 300,000 Panzerschrecks had been manufactured. The weapon equipped infantry across all German armed forces. Wehrmacht line infantry, Waffen-SS formations, Fallschirmjäger paratroopers. Any unit expecting to encounter enemy armor received Panzerschrecks in their anti-tank sections. The ammunition was the key to the weapon's devastating effectiveness. The shaped charge warhead used physics rather than brute kinetic force to defeat armor. Inside the warhead sat a cone of high explosive with a copper liner formed to precise specifications. Upon impact with the target, the explosive detonated from the rear of the cone forward in a carefully timed sequence. This detonation collapsed the copper cone inward under immense pressure and temperature. The copper did not remain solid. It transformed into a jet of semi-molten metal, traveling at approximately 8,000 meters per second. This jet maintained coherence for a fraction of a second, long enough to contact and penetrate steel armor. The jet did not push through armor like a solid projectile. It cut through. The extreme velocity and pressure allowed the copper stream to flow through steel as if the armor were merely thick liquid. Once inside the tank's fighting compartment, the jet and accompanying spalling fragments killed crew members and ignited ammunition or fuel. Secondary explosions frequently destroyed the entire vehicle. If you are finding this interesting, a quick subscribe helps more than you know. German infantry tactics emphasized patient ambush. Panzerschreck teams positioned themselves in locations where enemy tanks would be forced to pass. The high hedgerows of Normandy's bocage country, upper floors and basements of buildings in urban combat, tree lines along roads, anywhere that offered concealment and a clear firing lane. They waited, sometimes for hours, until Allied tanks came within 100 meters, preferably closer. 50 to 75 meters was ideal. At these distances, even an average soldier could achieve hits. The teams had time for one shot, perhaps two if they were exceptionally well concealed. Then enemy tanks would respond with machine gun fire and high explosive shells. Survival required firing and immediately relocating. That single shot frequently killed the entire enemy tank crew. British tankers developed profound fear of the Panzerschreck. The weapon appeared without any warning. One moment a Norman lane seemed clear, the next moment a rocket streaked from a hedgerow barely visible against the dense foliage. By the time the crew realized they were under attack, the rocket had already struck their vehicle. And if the shaped charge penetrated, everyone inside the tank died. The psychological impact on Allied tank crews was severe and cumulative. Tankers understood their armor provided effective protection against most battlefield threats. Rifle fire, machine guns, artillery fragments, even direct hits from smaller anti-tank guns could be survived. But the Panzerschreck simply ignored armor thickness. It killed through penetration, and the physics of shaped charge technology did not care whether the steel was 14 millimeters thick or 40 millimeters thick. Normandy's distinctive bocage terrain proved ideal for Panzerschreck operations. The region's agricultural landscape consisted of countless small fields divided by ancient earthen banks topped with dense hedgerows. These hedgerows stood 3 to 4 meters tall and were virtually impenetrable. The fields were connected by narrow sunken lanes with high banks on either side. British and American tanks advancing down these lanes had no room to maneuver. The hedgerows blocked visibility beyond a few dozen meters. German Panzerschreck teams positioned in the hedgerows could fire at point-blank range against tanks that had no warning and no space to evade. Dozens of Allied tank crews died in these one-sided ambushes during the weeks following D-Day. Urban combat presented equally deadly conditions for Allied armor. Buildings provided perfect concealment for Panzerschreck teams. They positioned themselves in second or third floor windows overlooking streets tanks had to traverse, or they fired from basement windows at street level, targeting the thinner belly armor as tanks passed overhead. In cities, tanks were blind and vulnerable. Panzerschreck teams were patient and lethal. Allied forces developed countermeasures, but none proved entirely effective. Infantry support helped significantly. Foot soldiers could clear buildings and hedgerows immediately before tanks advanced through contested areas. But Panzerschreck teams were mobile and patient. They would allow infantry patrols to pass, then engage tanks following minutes behind. Suppressing every potential firing position across an entire battlefield was simply impossible. Comparison with contemporary anti-tank weapons demonstrates the Panzerschreck's significant advantages. Against the American bazooka, the German weapon achieved clear superiority in penetration power and effective range. The 88mm rocket substantially outperformed its 60mm American counterpart. United States forces recognized this disparity and developed the improved 89mm Super Bazooka in the post-war period. Against Germany's own Panzerfaust disposable rocket, the Panzerschreck offered crucial reusability. The Panzerfaust delivered excellent penetration, but could fire only once before being discarded. The Panzerschreck allowed a trained crew to reload and engage multiple targets. A two-man team could fire, reload, and fire again within approximately 30 seconds. This made the weapon far more economical and tactically flexible than disposable alternatives. Against the British Piat spring-powered projector, the Panzerschreck proved simpler, lighter, and substantially more reliable. The Piat used a complex spring mechanism requiring significant physical strength to cock. The spring frequently malfunctioned under field conditions. Moisture and dirt caused failures. The Panzerschreck's rocket motor was straightforward and reliable. Fewer mechanical parts meant higher operational readiness. The weapon carried significant limitations that affected tactical employment. The massive backblast revealed the firing position instantly and unmistakably. Smoke and flame marked exactly where the shot originated. Enemy tank machine guns or supporting infantry could engage the revealed position within seconds. Experienced Panzerschreck crews learned to fire and relocate with extreme speed. Staying in one position after firing meant death. The blast shield added to later production models remained inadequate for complete protection. Gunners still frequently suffered burns to exposed skin and permanent hearing damage from repeated firings. Some crews improvised additional padding around the shield or wore extra protective gear. Despite these measures, the weapon remained genuinely dangerous to its own operators even when functioning exactly as designed. Ammunition proved bulky and heavy for dismounted infantry. Each complete rocket weighed approximately 3 kilograms. Crews could reasonably carry perhaps 6 to 8 rounds in addition to the launcher itself. Extended operations required dedicated ammunition carriers or frequent resupply. Units operating Panzerschrecks needed robust logistics support to maintain sustained combat effectiveness. Despite these significant operational limitations, the Panzerschreck remained highly effective throughout the final 2 years of the war. Allied tank losses directly attributable to Panzerschreck attacks were substantial, though exact numbers remain difficult to determine. Battlefield casualty reports frequently listed losses simply as anti-tank weapons without specifying the exact type used. The weapon's legacy profoundly influenced post-war infantry anti-tank weapon development worldwide. The Soviet Union developed the RPG-2 and later the legendary RPG-7, using fundamentally similar design principles: shoulder-fired launcher, rocket propulsion, shaped charge warhead, individual infantry portable anti-tank capability. The Panzerschreck proved these concepts worked under actual combat conditions, and every subsequent design built upon that foundation. Modern anti-tank guided missiles incorporate far more sophisticated technology. Wire guidance systems, tandem warheads specifically designed to defeat reactive armor, extended operational ranges exceeding several thousand meters, computer-assisted targeting. But strip away the modern electronics and the fundamental concept remains unchanged from 1943. An infantry soldier, a portable launcher, a rocket projectile that defeats armor through shaped charge physics rather than kinetic energy. The Panzerschreck pioneered this entire approach to infantry anti-tank warfare. Normandy, July 1944. The British Cromwell tank burns in the narrow sunken lane between towering hedgerows. Black smoke rises from the open hatches. The crew lies dead inside their armored protection. A two-man Panzerschreck team has already withdrawn deeper into the bocage. They carry their tube and remaining rockets. They will find another concealed position, and they will wait for the next Allied tank to advance down another narrow lane. Because that is what Panzerschreck teams do. They hunt, they wait with infinite patience, and they kill tank crews who believed their armor would keep them safe from a weapon they never saw coming. The German stovepipe proved decisively that shaped charge technology made traditional armor thickness calculations obsolete. One soldier with one tube and one rocket could destroy a tank costing thousands of pounds and months of factory production, and the weapon taught every Allied tank crew a brutal lesson they carried for the rest of their service. Sitting protected inside a steel box does not guarantee survival when the enemy carries weapons that turn your armor into your coffin.